These are notes on states or phases of matter. And you'll hear these two words, states and phases, interchangeably, meaning some people will say states of matter, some people say phases of matter, and it doesn't matter. You can use those words to mean the same thing. So when we're talking about states of matter, we're talking about solids, liquids, and gases. And I put them in this order for a specific purpose. So I'll show you what that order is as we go along. And you can see on your note-taking guide, these words are also in that order, solid, liquid, gas. So those are the three states or phases of matter. And we know that matter is anything that has mass, and anything that has volume, and anything that's made of particles. So those are the three ways we know things are matter. So any type of matter can exist as a solid, as a liquid, or as a gas. So here's some pictures. Okay, so this is water. Water we know is matter because it takes up space and it has mass, so it must be made of particles. And these are the three states of matter of water. So here we have ice, and we say that's ice, but what it is frozen water. Here we have liquid water, so if you're being really precise in chemistry, we would say liquid water, we wouldn't just say water. And then here you can kind of tell this water is bubbling. It's not a great picture, but you can sort of see that there's bubbles going on in this water. There's a bubble kind of coming up here and coming up there. Maybe, I think I'm going to get a new camera at some point, then maybe we'll be able to see it better. But these bubbles are water gas, or what we might call water vapor. And so whenever you have something that's boiling and you see those bubbles are not filled with air. Like if you're blowing bubbles underwater, those bubbles are actually water gas, water vapor. So that's kind of a little different than what some people think. So let's talk about phase changes. So meaning one phase going to the next, or ice becoming water, or water becoming water vapor, or we also sometimes call it steam, or steam becoming liquid water, or liquid water becoming ice. So solid to liquid is called melting. That's something I think most of us know. That probably isn't a new vocabulary word to most of us. Liquid to gas has two words. You could say evaporate, or you could say boil. The difference is boiling is a way of speeding up evaporation. So if I spill water on the floor, eventually it will evaporate. It's just going to go into the air as water vapor. I don't have to heat it up or anything like that, and we'll talk about why later, but it evaporates. Or if I put that water on the stove, right, I could turn it up and then turn on the stove and it would boil and eventually go out into the air as well. So the same thing happens. The liquid turns to gas. Boiling is just a lot faster than evaporating. Then there's one more, and that's subliming. And subliming is solid going directly to gas. Okay? And so that's what, like the dry ice that we all saw. Most of us are used to ice melting into liquid water, then boiling into steam. But the dry ice went directly from solid to gas, and that's called subliming. And that's also why it's called dry ice, because it doesn't have a liquid phase. Now, in real life, dry ice does have a liquid phase, but it doesn't exist as a liquid with the conditions we have in a normal room. So you would have to put a lot of pressure on it to get it to exist as a liquid. If you remember, some of you, that dry ice was carbon dioxide, right? So it's the gas that we breathe out. And we saw it as a solid, and we saw it as a gas. The place that you actually see it as a liquid, although you can't see it, is if you think of a jar or a bottle of soda, and when that jar, before it's ever been opened, it just looks like it's all liquid, but then once you open it, you hear it fizz and you see bubbles. Those bubbles are also carbon dioxide. But before you've opened it, there's so much pressure in that bottle that the carbon dioxide is still there. It's just in liquid form. That's why it's clearly not in solid form, or we would see chunks of dry ice, right? It's clearly not in gas form, or we would see bubbles. So the only other option is it's in liquid form. So you can make it be in liquid form, but you have to do stuff like add a lot of pressure. And any of these changes, melting, evaporating, or subliming, require you to add energy. So if you want a solid to melt, you've got to add energy to it. If you want a liquid to evaporate, you've got to add energy to it. If you want a solid to sublime, you've got to add energy to it. So just think in the back of your head, like, where did that energy come from when we had the carbon dioxide? All right, so then going in the opposite direction, gas to liquid is called condensing. You've maybe heard of condensation. That's the liquid that forms like on the side of a cup of water on a hot day. Going from liquid to solid is freezing. So for some reason, these vocabulary words, melt and freeze, are always a lot easier, right? We use these all the time. We know that water freezes and makes ice. These two words we don't use as much, and I think that's just because we have such limited understanding of gases, right? We're used to things freezing or melting, but we're not always used to things evaporating or condensing. And so these are two words, condense and evaporate, that you want to pay attention to. And if you're going in this direction, you must be removing energy. It's the opposite. So melting is the opposite of freezing. Evaporating is the opposite of condensing. So if on evaporating we add energy, on condensing we remove energy. And just like I said, think about where that energy comes from. Okay, like where did the energy for the carbon dioxide to sublime come from? One question too is, okay, then where does the energy go when something's condensed, if it's being removed? So sometimes we understand where that energy is coming from. If you look underneath this kettle here, it's red. Clearly the stove is on and it's hot. That energy is coming from the stove, right? We're adding energy to the water through the stove. Sometimes it's not as obvious. Does anybody, have you thought about it? Can you think about where that energy may have come from for the dry ice? That energy came from the air around us. So because the dry ice is so cold, energy from the air went to the dry ice, we added energy, and that dry ice sublimed. All right, so now let's talk about heat and temperature and the difference between them. Heat is energy transferring between two types of matter. So, for example, if I am holding onto an ice cube, there is heat transferring from my hand to the ice cube. It's energy transferring. Temperature is the average amount of energy in the particles of a type of matter. So temperature is like how hot or cold the particles in that type of matter are. So heat is actual energy. Temperature is a measure of the average amount of energy. And so when we say it's degrees Celsius or degrees Fahrenheit, that's temperature. When we're talking about energy and heat, we actually use something called joules to measure that, and that's an amount of energy. And heat always moves from hot to cold. So here's a picture of an oven that's just been opened, and it's very hot in the oven. I mean, you can't tell that from the picture, but I'm telling you. So if heat moves from hot to cold, that's energy. Now remember, energy is not matter. Those are the two types of stuff. We have matter, has mass, has volume, takes up space, that's volume, made of particles, and then we have energy. Energy has no mass, doesn't take up any space, has no particles, but it is this stuff that we have. So the heat here would go in this direction because the oven was very hot and the outside temperature was cooler. On the other hand, here's a freezer that was just opened, so very cold in the freezer. And so in this case, the heat would go into the freezer, warming everything up. That's why you don't want to leave your freezer open too long, because it's going to let a bunch of heat in, and then that's going to take more energy to make it cold again. Like the motor on the freezer would have to work more. Same thing, right? You don't want to open your oven too long while something's baking to check on it, because that's going to make all the heat go out. Then your oven's going to have to work harder to heat back up. All right, hopefully that kind of helps you understand heat and temperature and states of matter and phase changes. So now we all have some vocabulary that we can use together when we're looking at temperature and states of matter.